Hi, and welcome back. We are digging into a new lesson. It is our textbook section 5.4, and I'm splitting it into two parts. The first part is going to focus on solving quadratics using square roots. So we have already solved quadratics by graphing. We've already solved quadratics by factoring. And this is our third way of solving quadratics, is using square roots. Now we can only do that with some problems, but we want to use it when we can. It's a great method. So with this idea, we need to do a quick recap of something that we've learned in a prior chapter. We want to talk about breaking down square roots, because when we do this, we want our answers to be exact. We're not going to put them in decimal form. So when we go ahead and simplify square roots and rationalize denominators, we want to remember a list of perfect squares. So we should be really familiar with this, but I just want to throw this out here. Now's the time you could pause and rewrite this list if it would help you, just to sort of refresh. I have 1 through 12 squared, and we should be really familiar with these because of our times tables. These are the diagonal, 1 times 1, 9 times 9. And then I went ahead and went from 13 to 23. Maybe a little overkill, but these are our numbers squared. So good for us to reference. So your goal when you do this and you simplify a square root, your goal is to find the biggest perfect square that is going to break into it. And we are going to use that rule: the square root of a times b is equal to the square root of a times the square root of b. We're also going to use the rule when we have a fraction that we can break that up as the square root of a over the square root of b. So we're using our old rules. And again, I actually have that written down here real quickly. Square root of a times b, we want to find the biggest perfect square factor. You can use this method of dividing the number by 2 and then check each perfect square less than that half. And we always like to put that perfect square first. So that's just a quick reminder for you. All right, so you don't have to use a list, maybe you know them, but you would scan through your list and you would see that, well, 4 goes into 96 and so does 16, and you would check to see if anything higher goes into 96, and it doesn't. So we would break this 96 down to make it the square root of 16 times the square root of 6. All right, so again, I'm just using my perfect squares. I want the biggest perfect square, and that would leave me 4 square root of 6. Final cleaned up answer. I know that 16 was the biggest perfect square because 6 does not have any perfect square factors in it. All right, looking at our next problem, I have a 5 out front, so that's 5 times the square root of 180. So that 5 is going to hang out, and we want to break that 180 up. So I know that 9 goes into 18, so 9 goes into 180, but I was hoping to find something bigger. And I kept looking, and I believe 36 goes in. So sometimes it is just a matter of trying it. So 180 divided by 36. And we got 5. So again, if 180 divided by 2 is 90, I would start at 81, 64, and see what goes in. And 36 is the biggest perfect square. So I've got 36 times 5. And I've got the biggest perfect square because 5 is prime, doesn't have any factors that are perfect squares. And then this is 5 times that 6 times the square root of 5. So remember, the square root of 36 is just a 6. Bring down the leftover root. Final answer, 30 square root of 5. And there we go. All right, now we have a fraction. The first thing I want to do is I want to try to reduce the 18 and the 7, and they don't reduce. Next thing I'm going to do is I'm going to go ahead and break it down as a square root of 18 over a square root of 7. And here's where you have two options. One option would be to jump in and rationalize the denominator, so you have no square roots in the denominator. No square root in denominator. Okay, and so we would square that. So that's one option. I actually would prefer to hold off on that, and let's break down that 18 because I don't want to deal with a big number. So if you jumped in and you rationalize square root of 7 times the square root of 7, how do you get rid of a square root? You square it. You're going to get a bigger number up here. So I'm choosing to just take a minute and break that 18 down to a 9 and a 2. And that leaves me with 3 square root of 2 all over 7. All over the square root of 7. So I've broken that down. I've cleaned it up. But now I do need to rationalize it, so let me grab another color here. I'm going to multiply it by the square root of 7. Square root of 7. And by doing that, my numerator becomes 3 square root of 14. We're going to put the 2 times 7 together, and the denominator ends up just being 7. And that happens because that is the square root of 49. And that is my final answer. Now, before I can say it's done, I should check, can I break the 14 down with any perfect squares? And I cannot. And then the other thing is, could I reduce my 3 and my 7? Okay, and that fraction doesn't reduce, but the 14 and 7, we're stuck because that's a square root. All right, looking at number 4, if you jump in too quickly, you're doing a lot of work. So I don't want to break it up as square root of 72 and 3. I want to reduce first. And 72 divided by 3 is simply 24. So it's the square root of 24 over 1, or the square root of 24. That just got a lot easier. Now I will break down my 24 with the biggest perfect square. Square root of 4 times square root of 6. Final answer, 2 square root of 6. So this is something that you really need to be good at because we are going to use it. So it might be something you do a little extra work on. All right, let's get into the lesson. That took me a little longer than I wanted to. So there are a lot of quadratics that you can't factor. It doesn't mean that you can't solve them. It just means that the numbers don't work out to factor. So we have other options to solve them. And you know, graphing is a good method if you can find if there are real solutions in x-intercepts, and also if they're nice numbers. So equations can sometimes we can use that square root to solve them. Okay, so if I have an x squared, I can always take the square root of it, but I want you to remember there's always going to be a positive and negative answer. All right, and we haven't focused on that. So I want you to think about this. If I say x squared equals 9, well, x could equal 3 or x could equal negative 3. So I need you to remember that. If I go to solve this, 3 squared is 9, but negative 3 squared is also 9. All right? So when I say x squared equals 9 and you have this problem, x squared equals 9, and you come in and say, well, to solve it, to get rid of a square, I'm going to take the square root, and what I do to one side, I do to the other, and a lot of us would just simply say, well, x is 3, right? The square root of 9, if I put that in a calculator, square root of 9 is 3. This is the positive root, okay? We need to consider that it could be a positive or a negative 3. So whenever you take the square root, you're going to have 2 solutions. Now that's the very end when we take the square root. So let's go ahead and talk about these. The steps are here. What I see is I have a quadratic. Normally we were taking this and moving it over and setting our quadratic equal to 0. We were going for that ax squared plus bx plus c. Now I actually want to isolate the x squared. So I'm truly using my order of operations, but I'm going backwards. I'm going to get rid of any addition and subtraction first. So if it helps you, draw a little line there. I'm going to add the 4, and I get 3x squared equals 72. Before I take the square root, I need to isolate it. So I'm going to get rid of the multiplication by dividing. So divide both sides by 3, and I get x squared equals 24, which references what we just did up there. And then to solve this one, I would come in and take the square root of both sides. So how do I get rid of a square? I take a square root. And that's going to cancel and leave me just x. But before I forget, I want a plus or minus. And then I want to break that 24 down with the biggest perfect square. So I would get plus or minus 2 square root of 6. This is the exact answer. So if it doesn't specify to round it, you give the exact answer. Now, if I take the square root of 24, I will get 4.8989. So x is approximately 4.9. That is the approximate answer. If I typed in 2 square root of 6, I will get that same decimal. And remember, that is an approximate answer. Okay, Let's go ahead and flip it over. We have another one just like that to try. So I have 7x squared minus 23 equals 100. I'm going to work one step at a time. So I'm going to add the 23 and add the 23. So I have 7x squared equals 126. The next thing I'm going to do is get rid of any type of multiplication by dividing. And I get x squared equals 18. Now, if that didn't divide evenly and give me a nice integer, I would leave it as a reduced fraction. So no mixed numbers, no decimals, because we have to break our roots down. But at this point, I need to solve it, so I'm going to take the square root to cancel the square. And my next goal is to break that 18 down. So before I forget, I'm going to have a plus or minus, because a positive squared or negative squared can give me 18. I'm going to break the 18 down to a 9 and a 2. So I get a positive or negative 3 square root of 2. Again, that is the exact answer. This is what we are looking for. But if I wanted to check it, I would take the square root of 18, and I get that the approximate answer, x is approximately equal to 4.24. That is the approximate answer. If I put in 3 times the square root of 2, I should get that same approximate answer. Now, taking a test, I want to check my answer. I would go back up to the top 7 times, and I can hit my answer key. So 7 times the answer that I just had, square that, and then minus 23, and I should get 103. Now, if I put in 7 parentheses 4.24, I've rounded this, squared minus 23, I'm going to get really close to 103, but I won't get exactly that because I've rounded it. All right? But we can always check our work, so no reason to get these wrong. Now, I want you to notice what's missing in these. I've got the ax squared and I've got c, if I brought that 5 over. I don't have a bx. That's why I can solve these using square roots, because I can solve and isolate the variable and then take the square root. If I have an x squared and something with an x here, I have to use another method. So I can only solve if I have an isolated x squared, just the variable squared. All right, so take a minute, pause, and go ahead and do these next 2 problems. We'll go ahead and we'll add the 20, and I get 4x squared equals 25. Now in this one, I'm going to divide both sides by 4. Again, you always want to isolate. Please don't take the square root until the square term is by itself. So I have 25 over 4. And again, to solve this, we are going to take the square root. And so right now I have x equals a positive or negative square root of 25 over 4. Now, before I worry about rationalizing the denominator, can't this be broken up like a 25 over a 4? So I get x equals a positive or negative 5 halves, or 2.5. And there we go. All right, next one. It's a little out of order, but we can do that. So here's my line. I'm going to subtract 3, and I have negative 4x squared equals a negative 88. All right, I'm going to divide by a negative, and that's important because we can't take the square root of a negative number. And so we get 22. So I can deal with this, all right? I can come in and take the square root, and I will still always, no matter what, get a positive or a negative outcome, because I can square a positive and I can square a negative to get the same positive outcome. With 22, there are no perfect square factors. The only factors are 2 and 11 and 1 and 22. So it is going to stay as positive or negative square root of 22. Again, if I wanted to check this, I'd probably get the decimal and plug it in to see if it works. All right, in our next set of examples, we have a little more stuff going on, okay? In all of these, we got the x squared, we took the square root, we cleaned it up, we were done. And these, we're going to have an extra step. So first, let me remind you of your order of operations. There is nothing on the left to do. I can't distribute the 9 because I'd have to do exponents first. I cannot square this by just distributing it. I'd actually have to write it as 9 and then x minus 2 times x minus 2 minus 10. I don't want that. I want to get rid of things. So we really are following that order of operations each time. So draw that line if it helps you, and I want to get rid of addition and subtraction first. This is in parentheses with the power, so that's going to be one of my last moves. I'm going to add the 10 first, and I have 9, and then the quantity x minus 2 squared, and that equals 121. All right, the next thing I'm going to do is get rid of that 9. It's 9 times it, so I'm going to go ahead and divide both sides by 9. Now, here is the issue. I'm left with x minus 2 squared, and if I take 121 with, 121 fraction 9, and I try to simplify it, you might have a simplify key, I get 13 4/9. That's a mixed number. If I go back to the improper fraction form, there's no common factors. 9 and 3 don't go into 121. So I don't want a decimal, I don't want a mixed number, I actually want to keep the fraction. So this is one of those cases where we want the fractions to keep the exact. Now at this point I can't get rid of that minus 2 until I take the square root of both sides. Okay, well that's not so bad. Now here's where I take the square root. So I get a positive or negative right here, right now. It's not just slap it on at the end of the problem. It's right here, I get a positive or negative. And then if this is really the square root of square root of 121 over square root of 9, which is 11 over 3. Okay, so I'm almost done. I have one more step, which is to add the 2. And so when I go to do this, your answer looks like this, 2 plus or minus 11 over 3. I don't want to leave that answer. Guys, I know this is a fraction, but they're like terms. They're numbers. There's no extra square root here. There's no variable. So I should add these. I'm actually going to take 2 plus 11 over 3, and I'm going to come and take 2 minus 11 over 3. We're going to get two different answers, not just a plus or minus a square root. So when I go to do this, you can just throw it in the calculator, guys. 2 minus 11 fraction 3. All right, I get negative 1 2/3, or as an improper fraction, negative 5/3. So x is negative 5/3 or negative 1 2/3. If I go back up and I think I subtracted it. So let me flip-flop my answers there. Sorry, I did the subtraction first, so let me flip that. All right, that was subtraction. Now here's the addition. So if I add that 2 11/3, I get 5 2/3. So 5 2/3, or I can convert that back to an improper, which is 17/3. Okay, now let's just talk about this real quick. How do I do this without using a calculator? I would take that 2 over 1 minus 11/3, and I would get a common denominator, because we're going to have to do this in another chapter. And I'm going to have this as 6/3 minus 11/3, and 6 minus 11, there's your negative 5/3. And then I have my 2 over 1 plus 11 over 3. Same thing, get a common denominator. I get that again as 6/3, but this time I'm adding the 11/3. And you can see 6 and 11, 17 over 3. So just wanted to remind you of that. All right, let's keep moving here. Now, if you look at the next problem, I don't want you to be fooled by this. There's parentheses here, but the power's on the inside. So this was very different. When we did this, we basically isolated the square term and took the square root and had an extra step. These parentheses are just to distribute the 2. So in this one, you could distribute the 2, but I'm going to go ahead and just sort of follow these rules of subtracting off the 3 first. I have 2x squared minus 4, in parentheses still, equals 12. All right, now that I have that, I am going to just divide out the 2, but you could distribute it. I've chose to divide it out, so I have x squared minus 4 equals 6. And here's the deal. That power is only on the x, so I want to isolate that by adding the 4, and then I have x squared equals 10. So this really is like the other problems we did, and then I will come in and take the square root, and when I do that, I get x equals a positive or negative square root of 10. And the reason I don't break it down is there's no perfect square. Okay, so we are at the point where you're going to pause this and try these next 2 problems. All right, so here we go. I'm going to add 4. If it helps you draw that line, I cannot distribute that 3. I need to isolate the square term. So 3x minus 2 quantity squared is equal to 25. The next thing I'm going to do is divide that 3 out of there. So I have x minus 2 squared equals 25 over 3. Then I will come in and take the square root. All right, so again, I want to put my plus or minus sign right here because I took a square root, but I want to remind you 25 over 3 does not reduce. It's not a nice integer, so I have to leave the fraction. I'm going to break it up to the square root of 25 over the square root of 3. The square root of 25 is, we're going to put that positive or negative 5 there. The issue is that I have a square root of 3. So what we're really doing is once we hit the square root is we're just sort of stopping the problem and working with this. So I've got the square root of 25, but I'm stuck with the square root of 3. So I will rationalize it. So we're using our old skills here. And that gives me positive or negative 5 times the square root of 3 all over just 3. That would be the square root of 9, which is 3. So x minus 2 plus or minus, and I have this 5 square root of 3 all over 3. Okay, so I'm not done yet. I have one more step. I need to add the 2. And I prefer to put it out front, so my answer will look like this. Positive 2 plus or minus 5 square root of 3 all over 3. It takes a little getting used to, but the idea, you could put the plus 2 out here. I like it out front. The plus or minus is on the square root piece. This is our exact answer. There's no way that I want to take this mess and try to put it in here. So what I would do is take a minute. I think this is important to show you. If I want to try to see what the decimal is, it's going to take me a little effort. I'm going to have my 2 plus. I want to put this in parentheses because it's not going to make a difference in this one, but I'm going to say this is it's 2 plus, here's my whole numerator, 5 square root of 3. So here's my whole numerator divided by 3. The order of operations will work out in here. My decimal is about 4.89. So it's about 4.89. And then I would just come in and, whoops, I would just come in, which I can't because I've lost it, there it is, and subtract it and get the other answer. So 2 minus 5 square root of 3 over 3 is approximately negative 0.89. So if I want to check it, I would take that answer and I would put it up in here, that decimal. That would be the best way to check it. But remember, I want the exact. Okay? These are the approximate. All right, next problem. That one was definitely a lot. We're going to subtract that 9. So I get 3 and then x minus 2 squared equals 21. Again, divide by that 3 to get it out of there. This one works out a little nicer because I get a nice integer of 7. And then I'm going to take the square root to solve it. Square root, and I get x minus 2 equals plus or minus square root of 7. Okay, not done yet. I now need to add the 2. So my exact answer is x equals 2 plus or minus the square root of 7. I can't go any further with this. I can't take 7 plus 2. It's a square root. It's proper to put the integer out front, then plus or minus the root. Again, if I wanted this is the exact, if I wanted to check it or you were asked for the approximate, you would need to type in your calculator 2 plus the square root of 7. That is going to give you 4, so x is approximately 4.65. But we're going to get a very different answer. If we go in, we subtract, we don't just get plus or minus 4.65, we get that 4.65 or negative 0.645 or 65. Okay, a couple more, a little longer than I wanted it to. Looking at example 3, we are going to solve using the square root property. So here we go. I'm going to subtract the 7. I get 5x squared equals negative 67. And then when I go to divide by 5, I have an issue. First of all, one issue is 67 over 5 doesn't reduce. So I'd have to leave it as a fraction, but it's a negative. So when I go to take the square root, right now, I am stuck, okay? There are no real solutions. There are solutions, but there are no real solutions because you cannot take square root of a negative number. Now, we will be learning imaginary numbers, and that's why I'm saying there is no real solutions, because we are going to learn how to take the square root of a negative number using imaginary numbers, but we have to get there. All right, so looking at the next one, I'm going to come in, I'm going to add 3. So I get 9x squared equals negative 149. Then I'm going to divide both sides by 9. So again, a little messy because 149 and 9 don't reduce, but the big deal is that negative sign's there. Now if this was a negative 9 and I divided by negative, I'd have a positive, we could work with that. But again, I can't take the square root of a negative, so there are no real solutions. And I want you to think about this. Why can't I take the square root of a negative? Because nothing squared gives me a negative. Everything I square should be a positive. That's why there are no real solutions. I'm not saying the graph looks like this, but this is where you have a graph that never crosses the x-axis. That's when we get no real solutions. We have a graph that goes up or goes down, and there's no x-intercepts. All right. So now this is where you might be pausing and coming back to this, but I'm going to go ahead and finish this in one recording. We're going to go ahead and do our word problems. So again, this is a good place to pause and practice what we learned and then come back and dig into our application problems. We're going to do that now in one big video. So the rescue helicopter is hovering 68 feet above a boat that's in distress. A lift raft is dropped from the helicopter. The height in feet of the raft above the water can be modeled by the following function. All right, so picture a helicopter in the air, and they're going to drop this raft. All right, when the raft hits the water, it is 0 feet from the water. All right, right now it's 68 feet above the boat, and we're talking about the boat sort of being that level ground that we want. So negative 16 is it's our physics, it's our gravity, it's dropping, okay? So negative 16t squared plus that initial height, 68, all right? If you see something with the t in the middle, that is your initial vertical velocity. And since we are holding the boat steady and dropping it, we don't have any force that we're putting on it, it's just dropping it. That's why it's 0t. And because we only have a t squared, I can solve it. Now, t is going to stand for the time in seconds. T equals the time in seconds. It's important to define our variables. And h of t represents the height in feet of raft above the water. All right, so it says after being dropped from the helicopter, how many seconds will it take for the raft to reach the water? Well, when the raft reached the water, the height is 0 when it hits the water. So I'm going to take and replace this h of t with the 0, just like we did when we solved by graphing. and we solve by factoring. We set it equal to 0. We're trying to find, in this case, time when the height is 0. And that is equal to negative 16t squared plus 68. So yes, I could do a little factoring on this one, but not as much as I want. So what we're going to do, it wouldn't really factor well, we're going to go ahead and just solve for this. So I have negative 68 equals negative 16t squared. I'm going to divide both sides by negative 16, and I get t squared. And here's the deal, 68 divided by 16 doesn't divide evenly, but it's a word problem, so I actually want the decimal form of the answer. So I'm going to go ahead and not worry about breaking this all down. So I'm going to go ahead, because it's a word problem, and give an approximate answer. All right. So 4.25 is not my final answer. I would need to take the square root. So I'm going to come in and take the square root of 4.25. And I get 2.06. So t is approximately, and don't forget we have a positive or negative 2.06, but we know that we can't have negative time, so it is going to be about 2.06 seconds for the raft to hit the water. For the raft to hit or reach the water. Okay? Now, next part. It says, how many seconds will it take the raft to hit the water if the helicopter drops it from a height of 34? Well, a lot of you are looking at, well, it started at 68 at 34, so it's going to take half the time, but that's actually not true because it's not the same speed as it goes down. So I'm going to have that h of t, it's still going to stay negative 16t squared, but the initial height is 34. And we want it to hit the water, so again, it's going to be 0 feet above the water. So let's subtract that 34, negative 16t squared, divide by negative 16. Again, we're going to be approximating this, so I'll go ahead and take 34 divided by 16, the negatives divide out, and I get 2.125. I'm going to come in, sorry about the bells, and take a square root, so square root of 2.125, and I get that t is approximately positive or negative 1.46. We'll round it because it didn't specify what to round to. And if I look at this, that means about 1.46 seconds for that raft to hit the ground when it's dropped from 34 feet high. Okay, a couple extension questions here. If we made a graph of this function, whether we did the first one or the second one, would it open upward or downward? Well, because a is a negative 16, it would open downward. And with a graph that looks like this, opening downward, the vertex would be at the top, so the vertex would be a maximum value. Now, what is the vertex of the original function? Okay, so the original function was h of t equals negative 16t squared plus 68. So how do I find that vertex? Well, do you remember your formula? X equals negative b over 2a. So that would be negative 0 over 2 times negative 16, right? Because a is negative 16, b is 0, and c is 68. So x equals 0, that's my axis of symmetry, all right? So the vertex would be 0, 68, because h of 0 is going to be, whoops, I forgot to put the 0 in there. H of 0 is going to be 68. So that's my vertex. And if you wanted to know the maximum, the max value is 68 feet. Think about it. That's where the raft is starting, and then it's dropping. We are really seeing this go, this is over time. So your graph looks like, oh no, your graph, sorry, looks like this, where this is going to be dropping and hitting the ground, and this is your time, and that's your height. How can we relate the values in the vertex to actual real representation? Oh, well, there it is. The raft is 68 feet high before it is dropped from 68 feet high. 68 feet high is your initial height, and then we're going to drop it. So in 0 seconds, that raft hasn't moved. Okay, well, keep working on these, and we will talk soon. One of the big tickets here, whenever you're talking about something being dropped, something being kicked from the ground, when it hits the ground, means it's setting it equal to 0 if they're not giving you another height.